Hello everyone, welcome back to High School Tutoring. I am your host Manny, and we're going to be learning thrown down. Objects thrown down instead of objects dropped like we did in the last video. Again, still under the free fall topic, don't get confused with that. So, we're basically now doing anything that doesn't have v naught equaling 0. So v naught is going to never be 0 if you're throwing something, but it will be if you're dropping something. Our g value will stay the same because it's gravity. It doesn't really change unless you move positions in the world. It would go to 9.81, stuff like that. So let's just have a diagram to explain that. So we have our, let's just call it a rock, so we'll use R. This doesn't really mean anything, it's just to represent it. And let's say it's 3. And 3 is not equal to 0. So it is going at 3 meters per second, is thrown down. So we'll have 1, 2, and then etc. Until it hits the ground, obviously. And so now we want to find v final, obviously, at 1 second, let's say. So I have v final. We're going to use the same problem as last time, equals v naught plus gt. So now we have the problem. So we have 1 second, so that's that. And our g is 9.8, and our v naught is 3. So we're going to plug those in. So 3 plus 9.8 is 9.8 times 1 is just 9.8. And guess what that equals? It equals 12.8. Or 13, you can decide on that. Because when you're using sig figs, this has no decimal point, so we want to round up or round down depending on that. So we're not going to get into that. But that's just a simple example of what we're learning today. So let's get the problem here. So Jack throws down an apple at 5 meters per second off of the same 25-meter roof. How long will it take the apple to hit the ground? So again, now we're solving for time because of how long. We're solving for the final time because of hit the ground, not like when does it hit, like halfway or yeah. So now we're going to use our givens, and nothing in this problem says that gravity is removed or anything, so just 9.8 meters per second squared. And then so we have v naught now. That's going to be 5 meters per second, as explained in this problem here, as he's throwing it down at 5 meters per second. Now we could just go to displacement, which is the roof. Obviously, it's going to be 25 again, just because he's throwing it down instead of dropping it from the same roof. So, and then we'll look at our unknowns now. So our unknown, u and k will equal unknown again, just like last video. And we're going to look for time, obviously. And I'm going to add in v final. V final, the only reason I'm adding it in right now is to represent how v final can't actually be used in this problem, because we're not given it here, we're not given it in the problem. And v final, I'm just using it because it says hit the ground, so people might get confused, or actually not confused, but exactly, we'll just have it here to explain that we can't use it in the problem, and because it is a byproduct in a lot of things like this where you have to find v final after, so we'll just leave it there just as reference. So now we need a problem that we can use. So we're going to use d, since now we've used displacement, so we can cross that off. v naught t plus 1/2 gt squared. So v naught and g are now crossed off, and now we have t used twice. But we're going to have to use it like this, so let's get solving. So here we go. Now we have displacement, and here's what we have to do. Now obviously you might think, oh yeah, subtract v naught t, multiply by 2, do all that stuff. No, that's not what we're going to do. We're actually going to plug in everything first. The reason we're doing that is because when we have v naught t, and then we have to divide by t, this will still be dividing by t. Just because this t is here doesn't mean it cancels out. And v naught is now not 0. So we can't just leave it out of the equation like we usually do in dropped. So we're literally just going to have to plug this in. So 25 equals 5t plus 4.9. We're going to do 4.9 just to do this mathematically really quick. Since it's 9.8, divide that by 2. There you go. 4.9 t squared. So now we have the problem. Here we go. It's laid out for us. We could just solve this right now, but we're not going to. We're going to find it in standard form, which is ax squared plus bx plus c is equal to 0. And there we go. So this is the standard form for quadratics. You probably learned this in Algebra 1, and you're probably going to be using it for a little while. So we have that there. So our a value, since we have the t squared next to it, it represents the x squared here. Our a value is going to be 4.9, so or 1/2 9.8, doesn't really matter. You're going to have to do that math anyway. Our b value, since we have the variable next to it, the t variable, which corresponds to the x, that's going to be 5. That's going to be 5, representing the actual number here. And our c value, now, our c value may just say, oh, it's 25, right? No, because it's not. This is currently not equal to 0. So our c value is actually negative 25. Just imagine 5t plus 4.9t squared minus 25. Our c value is going to be negative 25 because this has to be equal to 0, and that just crosses it out. So yeah. So there is our values. So our a value is 4.9, our b value is 5, and our c value is negative 25. So we could just do that. So 0 equals 4.9 t squared, okay, plus 5t minus 25. And there we go, yeah. So now that we have everything, all of our data in standard form, we can start actually doing some real quadratics. So we'll have t here. This is long isolation. It was explained in Algebra 1, but I'm not going to do it. We're just going to do it here because physics doesn't really matter. So it'll be negative b plus minus square root b squared minus 4ac over this entire thing, including the negative b, over 2a. So this is our value, and this will be, it's just this problem isolated into here. That's it. So, and now we can just plug in. Realistically, we can just plug in. We have our b value, we have our a value, we have our c value. So now, and here's the thing that a lot of people get confused about. You're going to have to do this twice, only because of this symbol. This is a plus minus symbol, only used really with square roots and stuff like that. You'll see it in completing the square when you're doing algebra and some other topics. But this symbol basically means that anything that this comes out with must be positive and negative. So you can have, let's say we get 49, just a random number. That 49 can be positive and it can be negative, because if we square it, it'll go back to whatever was in the square root. Pretty simple. So yeah, we have that value now. And since you can square a negative and you can square a positive, we're just going to have this, so we're going to have to solve it twice. So we're going to have negative 5 plus minus square root of 5 squared minus 4.9 negative 25, and then that all over to 4.9. Now you can do this by paper, just by solving obviously in the square root first, and then you could do this bottom bit, which would be pretty simple, and then you can isolate it. So this would be negative 5 over 9.8, and then whatever here after square rooted, and you just have to solve it twice because it's plus minus obviously. So in this scenario, whatever you get here, you got to solve it once while it's positive, and vice versa when it's negative. So that makes sense. So we're just gonna grab our calculator to make this shorter on ourselves, and our value. So here's how we're gonna do it. I'm gonna show a couple steps. So what we're gonna do, quickly click alpha y equals on your calculator. TI-84 plus or higher, it'll be fine. I think TI-83 is pretty similar. They're both graphic calculators, should just work. And then we'll click n over d, which is numerator over denominator. And in this, we'll do negative 5. Don't use the minus symbol. It won't actually detect if it's supposed to be a negative 5 or minus 5. That's the only confusing bit. And then we're going to do, I like to start off with plus, but you can start off with minus. It doesn't really matter. And then we'll do second and x squared. X squared is one of the buttons under x over negative 1. You'll see it on the left under math. It's pretty high up. It's in the top left area. Around there, you'll find it. Just click second, then click that. And then now we have a square root. So in parentheses, we want to put 5. Mostly you put in parentheses just because of negative numbers, like negative 3, negative 4, like etc. Any number that's negative. You want to put it in there because sometimes, not all the time, but with some numbers, the calculator will get confused, and when you put a negative symbol to represent the negative number, it won't actually do it right. So I'll put 5 in parentheses. We're just going to do this for this example. And then click x squared again, and now we have 5 in parentheses squared. It's the same thing as just putting 5 squared, but yeah. And then we'll put the minus symbol instead of the negative symbol. 4, and then in parentheses 4.9, close parentheses, and then open parentheses again, and then negative 25. So there we go. Now we have the top bit all done. Under, you could just do this. It's pretty simple. It would be 9.8, but just do 2, and then parentheses 4.9, and then just click enter, realistically, and that's it. If you did it right, you should get a positive answer or a negative answer. If it says like an error, that probably means you used the wrong negative symbol. You either use the negative symbol for a minus or a minus symbol for the negative. And then, so now we have our first answer. And when the parentheses is positive, t is equal to 1.8 or 2. We can have that. So 2 seconds as that. And then when it's negative, here's how you would find it as negative. Either you can write out the entire thing or a little shortcut. Click second, then click enter. It will basically just bring that problem that you just solved back so you can edit it to whatever you need. And then you'd go up, you'd go through the square root, and then change the symbol before the square root. Just change it to a minus sign. Don't change it to negative. I don't know if the negative will like mess it up, but I don't know, to be honest. So we just click enter, and then our value that we get when it is negative, it is negative 2.8. These are much longer numbers, but here's now we have 2 answers. So you're gonna be thinking, wait, I can't have 2 answers in a problem like this. It only shows that we should have only 1 because of time. Well, you look here, and if you use any logic, time can't be negative. Remember that. Time cannot have a negative symbol in front of it because time doesn't go back. If time went back, we just say we went back a couple seconds, which isn't physically possible. So that means we'll just have 1.8 or 2. And there you go. And if you want to test this again, obviously, you could use a different problem, or you could just plug in 2 as this, which I'm not going to do, but you could do, because I've checked this already. I've already got the solutions for this. But yeah, that's realistically it. That's it for Thrown Down. So yeah, I hope you guys enjoyed, and maybe you learned something from it, maybe you didn't. This isn't the ideal example because there's more steps usually in some problems like this, where you have to find like v-final or any other thing after you find time. Mostly v-final though. So yeah, thank you for watching, and if you guys want to find v-final from this, yeah, you can just do that. There's a couple problems that you could do. Obviously, this equation on the left is a prime example. This one right here is the most prime example, just because it's the simplest. And yeah, you could just plug in 2 instead, have your v naught as 5, and yeah, you could just find for v final right there. And so yeah, that's all you gotta do. And I hope everyone is having a great day so far. And I want you guys to enjoy your days, you know, because high school is pretty rough. And yeah, I hope you guys had a good one, and I'll see you guys in the next video. Goodbye.